All right, in this video, we're going to learn about function notation. So you may have learned a definition of what a function is before. That's often written as, or a way to identify a function being anytime you have one output per input. So no more than one output per input. And the outputs here, that represents the y value or the dependent variable. And the input would be the x value or the independent variable. And in this unit, we're going to start also talking about this in terms of whether something is a function of something else. So this is just a fancy way of saying that a certain relationship is a function. So let's say, for example, we have just a tiny little baby graph, and we're going to have time on the x-axis, and we're going to have height on the y-axis, and perhaps someone tossed a ball and it went like that. We could say that height is a function of time. Because as time changes, the height goes up and then the height goes down, right? And as a function, this works if we consider, in this grammatical structure, it's always y is a function of x, right? The y variable is a function of the x variable. And if we look at this, you may have learned about a vertical line test before, right? To check and make sure there's not more than one output per input, right? There's not more than one y value per x value, and that's true. If we look at when time is 1, the height is a little over 3. The ball's not in 2 different places at once, right? It's only one spot. So this works. However, if I were to do a different graph, and if I were to try and have once again time and height, and if I were to try and go like that, then that would not work, right? The ball starts here and then it's like it splits, and now all of a sudden there's 2 balls because it's in 2 different places at once, and then they get further apart, and like, right? Like this is broken. This does not work. This makes absolutely no sense. This is not a function. So in this situation, height is not a function of time. We'd have to write it the other way. We'd have to say that time is the function of height, which that just gets all confusing and weird. We don't want that. So that is a nope. All right. Now, the new piece is function notation. So if I were to take let's talk about, this is function notation now. So let's say we have someone named Mia. And, well, actually, no, sorry. First, let's do just the general structure. So this is like our new y. So the x represents the input. The f, that's like the name of the function. It's f stands for function, right? That's like the default one, but we can use other variables if that makes more sense in context. So f kind of stands for the name of it. And then it equals the output. So let's say, for example, that we're going to say that h of t equals Mia's height in inches. And t is going to represent Mia's age in years. So then we can write a statement using this format and interpret it. So let's say that our statement is h of 11 equals 60. Now, I should have said this earlier. That F and that 10, those are not multiplying. That is just, this is the whole thing is sort of like saying Y equals output. The X and the F combined together create just like one structure for a function notation. There is no multiplication involved. So this does not mean H times 11. We say this is H of 11. And so if we were to write this as a sentence, we would say that Mia was 60 inches tall at 11 years old, because that's what the information that we have here, right? The 11, that's in the place of the T, that's her age. The 60, that's the output, that's her height. We also could write H of T equals 55. So this is more like a question. It may not look like a question, but it is. So this is kind of like asking how old was she when she was 55 inches tall? And there might be multiple X values that give you a height of 55, right? Maybe when she was ages 8 and 9, she didn't really grow. She just stayed the same height the whole time. That happens. So in our definition of a function up here, you can only have one output per input, but multiple inputs can give you the same output, right? Just like how someone could be the same height for multiple years in a row. Happens to adults all the time. You also could write H of 2 just by itself with no equal sign. So this would represent, this is also kind of like a question. This is saying, how tall was Mia when she was 2 years old? Right? I'm only giving half of the information, so then the other half is like implied, like that's what we're looking for. So here, since I'm giving you the input, right, it would not, there's only going to be one answer to this, because you can't be multiple heights at the same age, right? When you're 2, you're one height. Now, maybe you're a different height at the beginning versus the end of being 2 years old, but that would be like 2.0 versus 2.9. If we're actually talking about 2, there's only one possible height there. So this is, once again, there's only one output per input. If the input is 2 years old, there's only one output that's allowed. All right. Other thing I want to talk about is how we can use this as an equation. So just like this is kind of what I was trying to explain over here. So we're very used to working with functions like y equals, let's say 5x minus 4, right? This can just be a new way to write that. So we could instead say f of x equals 5x minus 4. So notice how the y has just been replaced with this f of x. That's all that means. It's just kind of a fancier way of doing that. Sometimes it can feel pointless. Like, why do we need to change it? The whole point of changing it is because it allows us to track the input and the output within the same phrase, and it can be very convenient. So let's say I wanted to know when x is 10, what is y? What's the output when x is 10? So using function notation, I would write it f of 10 equals 5 times 10 minus 4. So I'm tracking what the input was here, and then I'm just doing the math on the other side the same as I normally would. So I'd say f of 10 equals 50 minus 4. So f of 10 equals 46. And so that would be my answer. Right? So you can see how, compared with just finding a y output, like the 46 is my y, right? That is my output, but you can still see the input as part of the phrase. So it's like a helpful way to write things. All right. And just to be very clear, these are the same. Okay. Practice problem. All right, so new function. Let's say that g of x represents the gallons of gas, x represents the miles driven. What does g of x equal 1 mean? Or what does g of x equals 1 represent? Represent is better. I'm looking for a sentence here, just like one of these sentences that I wrote over here. Okay, good luck.